We hope you enjoy this video from Level 5. Don't forget to subscribe and turn on notifications for all the updates. Hi everybody, it's Alex from Level 5. I'm here with Joe Putney from Robotic Research. We're inside an Olli bus, which as you may know is manufactured by Local Motors. So if you want to hear more about the manufacturing process, I'll be doing another interview. So check the link at the end of the video to see more about that. There's a 3D printed vehicle. It's kind of interesting and unique. But first of all, we're going to talk about the technology and the software inside the bus and of course the sensors on the outside of the bus. Joe, talk us through it. We've got LiDARs I saw and GPS on the roof as well.
Right.
Have you just got the single channel or is it dual channel GPS?
Dual channel, yep.
And is that time corrected with RTK?
Yes.
So you've got presumably a local cell tower dialed in, or you've got your own kit here giving you an extra time booster signal. If that jargon's all fresh to you, RTK is real-time kinematics, and what that is, it's a time signal from the local cell network that's then enhanced, and that helps to correct a GPS signal from up there because GPS is not that accurate. And so there's interference in the atmosphere, and there's also a big mathematical problem with calculating GPS location down to a few centimeters. So you need to correct those signals in order to gain that accuracy. So with dual channel and RTK, that gets you down to about 3 centimeters or thereabouts. And if you don't have the RTK, and let's say you're only using a single channel like you would in, say, a mobile phone on your Google Maps when you want to find a shop or go to a friend's house that you haven't been to before, that mathematical problem of calculating location based on the time signals coming from GPS satellite networks is massively more difficult. That means that the accuracy is between 10 and 20 meters. That's no good when you've got an autonomous vehicle. Anyway, we're in a slow-moving vehicle. The Olli is a very well-established autonomous vehicle platform, but Robotics Research, talk us through the technology. What else has your company developed?
So we're historically a government contractor.
Okay.
We provided a lot of technology for the military for the U.S. And so what we did over the last 5 years is basically transition a lot of that technology to the commercial side, and that's when we teamed up with Local Motors to provide the autonomous capability for this platform. So interfacing with perception sensors, generating route plans, localization, all that, and also intersection behaviors, precedents, and things like that.
So what takes priority when you come across either a stop line, for example, or you have pedestrians in the road and so on?
Right, it's a combination of things. It's based off of the traffic rules. So if you have a stop sign, and multiple stop signs, there's precedence rules. Even without stop signs, there's right-of-ways. If the vehicle's coming from the right, with crosswalks, obviously the pedestrians are the right-of-way. So all those rules are accounted for, and then we generate a route accordingly. You mentioned localization there. What are you using specifically apart from the GPS, geofenced areas? Are you looking at SLAM as well, and have you got a vision system? Right, so our approach is how to create basically a redundant system, a safe system, right? If one particular technology were to fail, that we could account for it. And so we make use of a lot of different sensors. So we have the regular GPS, we have RTK as we mentioned earlier. Yep. We have wheel encoders, inertial measurement units. You're looking at the
odometry of each wheel as it turns.
Exactly. Yep.
And are these two-wheel steer or four-wheel steer?
Two-wheel steer.
They're two-wheel steer. So you've got a trailing wheel, and are you tracking all of the wheels, even the ones that aren't turning? I remember speaking to somebody in a Formula student team a couple of years ago, and they said that they believed they could have a very high level accuracy based on that alone. So it's interesting to hear that you've got odometry as a...
Well, it doesn't work if your wheels are slipping.
Right, exactly. Because I was going to say, it only really works if you've got a very high degree of confidence in the amount of traction that you've got.
Right, and generally speaking, like your trailing wheels will be more accurate than your driving wheels, because your driving wheels will slip first.
Yeah, and you've got side-to-side motion on your differential.
So the key is how to create the redundancy in all the different sensing capabilities. We have the GPS, we have the position, we have the inertial system. We also use our perception sensors for registering our errors. So basically triangulating off of artifacts in the environment rather than triangulating off of GPS as you would with the GPS antenna.
Okay, so have you got SLAM in this as well?
Yes.
That means that you can change the environment dynamically and it can react to it, which is reassuring, I guess.
And you can operate in places where you don't have GPS.
Right,
exactly. Underneath overhangs.
Urban canyons or
tree canopy.
Another bit of jargon there. Actually, two things you mentioned. The urban canyon is important because you have GPS signals which are coming from space, and and they bounce off buildings, and that means that, well, the signal gets messed up because it's coming from a different direction. Maybe it's bouncing off a building and hitting you at an angle that's 45 degrees different. And you mentioned tree canopy. This is something that I've talked about previously in the UK especially, where you've got rural lanes with trees over the top, and especially just after it's rained, there's lots of water suspended on the tree canopy, and of course leaves are full of water as well, and that is enough to stop GPS signals from coming through.
The GPS signal itself is extremely weak.
Yeah.
So it doesn't penetrate.
It's only a few watts, and it's coming thousands and thousands and thousands of miles through
Exactly.
space.
It doesn't penetrate foliage very well, and it's easily jammed actually. So if you're in a very noisy environment, GPS can get jammed pretty easily.
Yeah.
So you have to be able to account for that.
There's also aggressive jamming undertaken as well. I was in Amsterdam, and I remember seeing a news story that the newspaper had looked into GPS signals being jammed, and they found just in central Amsterdam from the newspaper office, I think it was about 25 different sources of physical jamming being undertaken in a city centre. So you've got potential cybersecurity threats through GPS signals which can be hijacked potentially. So the redundancy is really, really important. Let's go back to the hardware on board. What's the processing platform you're using? Now, I've seen in the past that the Olli uses the IBM Watson platform. Is that still the case?
So when you have a driverless platform, you no longer have a driver to talk to and ask questions.
Right. Okay.
And so IBM Watson provides that experience that you would, the interaction with the driver. So, hey, what is this building to the left? Or how long is it going to take me to get to the next stop? Or what is the next stop? If you don't have a driver, you can't ask the driver those questions. So that's where IBM Watson plays a role. Our system, the auto drive system, is what provides the obstacle avoidance, obstacle detection, mission planning, those kinds of things.
Right, and the hardware that's running on, is that a generic platform, PC-based, Linux-based, or is it one of the NVIDIA systems?
We use a mixture of different technologies, some embedded technologies and some more Linux-based platforms. But we use a mixture. And
the computer vision system that you use or you do your R&D with, is that entirely bespoke, your own system, or are you dropping into other existing libraries like TensorFlow and Caffe and so on?
We definitely make use of technology that's out there, a variety of different technology out there, yes.
And what do you find is the most relevant to your organisation in developing autonomous vehicle software? What should people out there who want to learn about these technologies be familiarizing themselves with?
If you're interested in deep learning and things like that, TensorFlow is a good tool. There's a lot of different, obviously TensorFlow is not going to help you with other type of applications, but there's a lot of things, OpenCV, a lot of variety of libraries out there that are open and good for learning.
And how did you get into this? What was your educational background before you started?
I'm a graduate of Virginia Tech. I competed in the Grand Challenge, the DARPA Grand Challenge. I'm not sure if you're familiar with that.
Yeah, absolutely. I think everybody must be, right?
Right. I competed in the second challenge for Virginia Tech.
So that's the urban?
It was the one before the urban.
Right.
Right. So I was the software developer for the planning system on that platform. Enjoyed it and went from there.
Right. What year was that Grand Challenge that you took part in?
It was 2006. The competition itself.
So here's the thing. In the research that I've done, I've found more than twice as many people in the autonomous vehicle sector have 10 years experience or more than with 1 year experience and more. So at the moment, a lot of the experience and the expertise is at the top end of the industry, so the technical leaders like yourself. And there's not enough new people coming into the industry to fill the
I think it's changing. There's a lot of education programs now targeting robotics. 10 years ago, there's only a couple universities that focused on robotics, and robotics is in nature interdisciplinary, so it requires electrical experience, mechanical, software, systems engineering, safety and validation, quality control. It runs the gambit.
It's very broad as well, which means it's very difficult to...
Right, so a lot of universities have each one of those broken out, and then there's been a lot of progress over the last decade in shifting that to targeting to robotics. Still have a lot of ways to go. Generally speaking, our strategy has always been try to recruit talent and then train the talent.
Right, so get somebody who's technically minded and gifted in maybe one area, like software development or whatever, engineering, and then push them forward into other areas with your experience. Is that because as an organisation you feel that universities just can't give the proximity to the knowledge and the experience that you've built up over the decades or so?
Well, even, if you're doing an undergraduate, it's just not enough time to get the real, true experience that you need to be, there's so many things that you need to learn before you become, knowledgeable enough to be able to design it. So,
and what do you think of this new, in the last couple of years, Chris Anderson, former exec editor at Wired, he's created this new program called DIY Robocars, which is a really exciting program. Please do get involved in DIY Robocars if there's a meetup in a city near you. Basically helps people on that journey to start learning about computer vision and robotics control and so on, and it's entirely self-driven. Forgive the pun, but people can buy the components from online, and they can start teaching themselves the methodologies and the skills required, and then race around a track.
Right.
Like
I think it's fantastic. One of the things that we do have to watch out for, though, is a lot of the tools now have become developed enough that you can just use it, so you don't really understand it. So that's the big thing.
So like an API, you don't necessarily understand what's going on behind the...
Right, if you're using, an NVIDIA system,
you're
using their API, or like an OpenCV, you're using their API, you don't really understand the fundamentals.
Right.
And so sometimes you get into a bind where you're putting pieces together, but you don't really understand how it works and what the weaknesses are and the advantages are. It's also important not just to just use the tools, but to understand how the tools work.
Well, I can't think of any better way to sign off than really know your tools and understand how they work. If you enjoyed the video, don't forget to like, and no, it's down there. Subscribe there, and like there, and we'll see you soon. Thanks a lot. Bye-bye. Thanks for watching this video by Level 5. Don't forget to follow us on Twitter @Level5Jobs and check out our website level5jobs.com.